Good morning po, ma'am.
Okay, so for this particular follow-up, we are going to discuss the first part of the chapter, electronic structure of atom. So for this topic, we will be covering 3 learning competencies. So you will see here the key terms: quantum numbers, electronic configuration, and orbital diagram. So um, you expect to emphasize on these key concepts that you see in the learning competencies. Any clarifications or questions you want to raise before we proceed? So while watching the video lesson, meron po ba tayong na take note na kailangan nating i-clarify or itanong? Anyone? None. Okay. Ito naman yung scope ng topic na to. So we will be going over the subatomic particles, electron configuration, orbital diagram, quantum numbers, plus the magnetic property of atoms. First, let us define an atom. Sige, I need volunteers. Miss Howard, Angelica, what is an atom? Unmute po.
Sorry po ma'am, napindot lang po.
Okay, Rodriguez, John Derrick.
Good morning po, ma'am. Atoms are the smallest fundamental particles of elements that make up matter.
Okay, so we can simply define atom as the smallest particle of element. Or in general, they are the smallest building blocks, fundamental units of all forms of matter. Atoms were discovered by Democritus, but first proven experimentally to exist by John Dalton. There were theories that came after the theory of Dalton about atom. And in fact, in the video lesson you viewed, there were some theories mentioned or discussed. Can you give me one? Check your notes. Ano-ano yung mga theories or ideas na na-cite dun sa lesson natin? Yes, Miss Fiona?
Wave theory po.
The Bohr's theory. Others? Mr. Portuguese?
Quantum theory po.
The quantum theory. Any other? Miss Bautista?
Bohr's theory po.
Bohr's theory given. Meron pa ba? May na-mention pa ba doon? Miss Kilnet?
Wave theory po.
The wave theory. So one of the most important theories mentioned there was the wave theory. Because that is most connected to quantum numbers. Ayan, na-mention na natin yung theories. What about the subatomic particles? Sabi ko nga, after the theory of John Dalton, more scientists explored atoms. So what were these subatomic particles discovered later after that? Can you give me the 3 subatomic particles? Ayan, yun na yung clue. 3 subatomic particles. Mr. Ramirez, what are the 3 subatomic particles?
Protons, electrons, and neutrons po.
Okay, very good. The protons, electrons, and neutrons. To distinguish the 3, protons carry positive, electrons negative, and neutrons no charge, uncharged, neutral. According to their position in the atom, both protons and neutrons are inside the nucleus. Electrons are outside. Ito. Okay. In terms naman of the relative masses, neutrons are the heaviest, electrons are the lightest. Discoverers, we have J.J. Thomson for electrons, Goldstein for protons, and Chadwick for neutrons. I'm not sure if I had mentioned this to you in one of our follow-up discussions, but let me just go over. There are properties of atoms that distinguish them from one another. But there are two distinguishing properties that we can get from the periodic table. We have atomic number and mass number. Let's take a look at our periodic table. Again, atomic number and mass number are two distinguishing properties of atoms or elements in your periodic table. Meaning, there are no two elements that share the same atomic number nor mass number. Kaya distinguishing properties. Can you look at oxygen? What is the atomic number of oxygen? Yes, Miss Angelica.
Good morning po. Number 8 po.
Okay, good. What about 8? What then can the atomic number provide? Atomic number actually gives us the number of protons. So if oxygen's atomic number is 8, then it provides us the number of protons located in the nucleus of a single atom of that element. There are 8 protons in the nucleus of a single atom of oxygen. What about the mass number? How do we approximate the mass number using the periodic table? Okay, who can give me the mass number of oxygen? Mass number of oxygen. Anyone? Yes, Mr. Tabar?
Good morning po, ma'am. 16 po.
16. How did you get that? Sabi ko nga, ang nasa periodic table natin is not actually mass number, but atomic weight. Atomic weight is the average mass of all the isotopes of an atom. So, in-average yung relative masses ng lahat ng isotopes. So, for us to approximate the atomic mass when doing stoichiometric calculation, for example, I ask you to have the atomic weight rounded off to the nearest whole number para mas madali sa ating mag-calculate, mag-mental calculate. Pero when you go to college, you will be required to express or write the atomic masses in at least 2 decimal places. But again, for the purpose of simplifying quantitative chemistry or stoichiometric calculations in Chem 1 or even in Chem 2, I ask you to round off the atomic weight from the periodic table to the nearest whole number. Okay? For the mass number, the rounded off atomic weight gives us the mass number. Ano ba yung mass number? If atomic number gives us the number of protons, mass number gives us the sum of both protons and neutrons. And anyway, these are the particles that are found in the nucleus. So Pag mass number, we are inferring for the number of particles in the nucleus of an atom. So, kunin nyo lang yung difference ng mass number tsaka atomic number, you can get the number of neutrons. Kasi nga, ang mass number is the sum of the two subatomic particles. So, referring to our periodic table, we have inferred that the atomic number of oxygen is 8. So, that gives us 8 protons, 8 electrons, and 8 neutrons. And ma'am, how come na pare-pareho sila? Nagkataon lang po. Again, the number of protons is the atomic number. So whatever atomic number you get from the periodic table, that gives you the number of protons in the nucleus of that atom. For neutral atoms, that is, walang positive or negative, neutral, ibig sabihin, the number of protons is equal to the number of electrons. So kung ano yung number of protons in that neutral atom na nakuha ninyo sa periodic table, that gives you the same number of electrons outside the nucleus. So there are 8 protons and 8 electrons in the neutral atom of oxygen, an oxygen atom. Para naman sa neutron, sabi ko nga earlier, after getting the mass number from rounding off the atomic weight of the element in the periodic table, that gives you the approximated mass number. And since mass number is the sum of protons and neutrons, isubtract lang natin. Mass number, una muna sa nuclide, di ba? A minus Z sa nuclide. Minus lang natin sila, subtract lang to get the number of neutrons. Let's take a look at potassium. Sa periodic table natin, ang atomic number ng potassium is 19. So that gives us the number of protons, 19. And since we're still talking about this neutral atom of potassium, the number of electrons is also 19. What about neutrons? From the periodic table, we round off the atomic weight of potassium to be, potassium is, malinaw yata dito, 39.0 something. So that will be rounded off to 39. So 39 mass number minus atomic number 19, that gives you 20. So pag inad mo ulit si protons and neutrons, you will get 39, which is the mass number of potassium. Can you look for silver? Can you give me the number of protons, neutrons, and electrons for an atom of, in an atom of silver? Anyone? Raise your hand. Other hands? What about the others? Other hands? Yes, Mr. Apas, Romerd.
47 po.
Correct. 47 protons, electrons.
47 din po.
Okay, and neutrons. Yung subtraction natin. Mass number is 108. Tama ba yan? Tingin ko dito. 108 minus 47 equals
61 po.
61. Very good. So that's how we use the periodic table in determining the subatomic particles of an atom. This is too important because as we go along, we will need this data. To continue, let's have the wave mechanics. Will you read Miss Cruz? What does it tell us, the wave mechanics theory? Basahin lang natin ang notes natin, kung ano yung isulat natin. Yes, Mr. Anil. Juan, Antonio.
Good morning po, ma'am. Wave mechanics. Electrons are not revolving around the nucleus in orbits.
Okay, very good. So according to the theory, electrons, bago to, nauna yung kay Niels Bohr. According to Niels Bohr, electrons are moving around the nucleus, revolving in certain orbits. Kaya orbital theory of Niels Bohr. But that was disproved by the wave mechanics. According to the wave mechanics, electrons are not actually revolving around the nucleus in orbits, but are located in certain regions around the nucleus called orbitals. Were you able to get the definition of an orbital? Yes, Miss May? Yeah. Ashley?
An orbital is a region around the nucleus where there is a high probability of finding an electron.
Very good. An orbital is different from orbit. So parang ang orbit parang yung sa Earth natin, di ba? The moon revolves around the sun in an orbit. So ang orbital means different. It's a certain region, a portion around the nucleus where there is high probability. This is the region around the nucleus where electrons are most likely, most probably located. So ito yung pinaka probable position or location of electrons around the nucleus. So dito po iikot yung ating topic on, first few topics on this chapter. So recalling your high school chemistry, you discussed the 4 types of orbitals. We have s orbital, p orbitals, and d orbitals, and f orbitals. So we have 4 different types of orbitals. We have one type of s orbital, ito, and its shape is spherical, sphere, bilog lang siya. P orbitals come in 3 types, labeled as P sub x, P sub y, P sub z. This is just to indicate that there are 3 possible orientations and therefore 3 types of p orbitals. We have, ang shape nun is described as 2-lobe or dumbbell. D orbitals are 5, labeled as D sub x, z, and so on. If we have 2-lobe p orbitals, we have 4-lobe d orbitals, except for the 4th type here kasi nagkaroon ng formation ng sigma bond, nagkaroon ng overlapping, kaya nagkaroon ng formation ng sigma bond. But generally, they are described as 4-lobe orbitals. And then, hindi naka-indicate dito kasi mas complex yung structure ng f orbitals. So you will notice the number of orbital types to start from 1, and then 1, 3, 5, 7, and so on. Ang f orbitals are described as flower-like orbitals. So mas marami, kung dalawa yung petals ng P, 4 yung D, mas marami yung petals ng f orbitals. But it comes in 7 different orientations, so 7 types of 7 different f orbitals. You will see right below, either to the left or to the right of your periodic table, what we call the electron distribution mnemonics. What about the mnemonics? This helps us in assigning or distributing electrons in the different orbitals. Talking about orbitals, let us mention already electron configuration. So this electron configuration mnemonics helps us distribute appropriately, correctly, the different electrons in the different orbitals in an atom. The reason why it's called the chapter is called electronic structure of atom, because we are trying to describe the position of electrons in an atom. Kasi ang kasunod na nito, chemical bonding. Ano bang particles ang nagte-take place or nagte-take part sa chemical bonding? Hindi ba ang electrons? Because electrons are outside the nucleus. They are mobile. They are the ones that take part in chemical bonding to form different molecules and compounds. So it's important that we know the position or the location or description of electrons in an atom. Okay, just in passing, let me tell you the 4 quantum numbers. Although it's impossible for us to have this covered kasi we have limited time. So mag-focus muna tayo sa electron configuration kasi connected naman ang quantum numbers sa electron configurations. Mind you, you need to first understand completely electron configuration before you can understand quantum numbers. So in passing, let me mention the 4 quantum numbers. The principal quantum number denoted by small letter italicized n, azimuthal quantum number denoted by italicized letter L, magnetic quantum number by M sub L, and spin quantum number M sub S. Remember that we are talking about positions, descriptions of electrons in an atom. Principal quantum number gives us the main energy level. Level, ibig sabihin, you are considering a certain positions in levels. Kumbaga, kung ito yung atom, meron siyang mga level. Level 1, level 2, level 3, level 4. So considering quantum numbers, main energy levels are the principal quantum numbers. So kung meron tayong main energy level, meron mga sub-levels. They are the azimuthal quantum numbers naman. Magnetic quantum numbers are the orientations of orbitals in space. So we have mentioned the 4 types of orbitals, the S, the P, D, and F orbitals. Kaya tayo may iba't ibang P orbital, D orbital, and F orbitals because of the orientations in space. Ang orientation ay nakabase sa Cartesian coordinate system. Bakit tayo may 3 na P, bakit tayo may isa lang na S, bakit may 7 na F, at bakit may 5 na P. We will have that in detail as we go along. Pagdating naman sa spin, we consider only 2 spins, clockwise and counterclockwise. Ano to ha? Electrons to. They are spinning in an orbital either as clockwise or counterclockwise. So ito po yung representation or nagsa-summarize ng possible position of electrons in an atom. So suppose you have the nucleus from an atom. Ito po yung pinaka-atom natin. Sundan yung cursor ko. Ito yung atom. At the center of the atom, we have this dense portion called the nucleus. In the nucleus, we can locate the 2 subatomic particles, neutrons and protons. At wala silang kinalaman sa chemical bonding. Nandun lang sila. Ang naapektuhan lang during formation of compounds or molecules ay yung mga electrons. They take part. Hindi na-alter ang subatomic particles na neutrons and protons during actions or during activities of the whole atom. Kasi electrons lang ang kadalasan na nagtitake part. Okay. From the nucleus, we have levels. So ito yung binanggit ko kanina. Level 1, level 2, level 3, level 4, level 5, hanggang level 7. Saan ito makikita? Sa periodic table ulit. Meron tayo dong mga rows. Periodic table. Ito. Row 1, hydrogen, helium. Row 2, row 3, row 4, hanggang row 7 to. Yung mga rows na yon ay ang mga energy levels. So kung ililink natin sa quantum number, they are the main energy level. Main energy levels are denoted by N, but assigned with numbers, whole numbers 1, 2, 3, 4, 5, 6, and 7. So pag nakita kayo ng N that is equal to 1, ang assumption natin that is first energy level, level 1. From the nucleus, syempre, from the nucleus, the nearest energy level is 1. As we go higher, as we go farther, we are increasing the energy level hanggang energy level 7. Energy level 1, energy level 2, or principal quantum number 1, 2, 3, 4, 5, 6, hanggang 7. Okay? Yung mga sub-levels naman ay, ang values naman nila, so kung ang main energy level ay, ang assigned values ay 1, 2, 3, 4, 5, ang sub-level naman, ang assigned values nila, hindi nagsisimula sa 1, kundi sa 0. 0, 1, 2, 3, 4, 5, hanggang 6. Okay? Pag nasa first energy level ka, it follows na ang sub-level mo ay isa lang. But the value is not 1, but 0. So again, pag nasa first energy level ka, the value of N, main energy level, is 1. The value of sub-level, azimuthal quantum number, is 0. Pag nasa second energy level ka, the number of sublevels is also 2. The values are 0 and 1. Pag nasa third ka, tatlo, 0, 1, 2. Pag nasa fourth, 0, 1, 2, 3. Pag nasa fifth, 0, 1, 2, 3, 4. So that's how we assign values for the azimuthal quantum numbers or sublevels. Yung mga orbitals naman, corresponding din kung ano yung energy level, yun din yung bilang ng sublevels at saka ng orbital. So kung nasa first energy level ka at isa lang din yung sublevel, isa lang din yung orbital. And that only orbital present in the first energy level is S orbital. Pag nasa second energy level ka, dalawa yung sublevels, ang azimuthal nun ay 0 and 1. Ang orbitals present in the second energy level is 2 din. At ang orbitals na yon ay S at saka P. Pag nasa third ka, tatlo. S, P, and D. Pag nasa fourth ka, S, P, D, and F. Wala pa tayong kasunod na type of orbital. From fourth energy level up to the seventh, 4 lang yung types of orbitals. S, P, D, and F. Let's have this summary. Okay. Medyo shortcut lang tong summary na to. There is more detailed. Okay? Again, when you are in the first energy level, the value of principal quantum number is 1. The only available orbital there is S. Bakit 1S? Bakit sa configuration 1S, 2S, 3S, 4S, 3P, 2P? That is to give us the main energy level. Ibig sabihin, yung S orbital na yun, nasa first energy level. Kung 2S yan, ibig sabihin, nasa second energy level. Kung 3S, nasa third energy level. So ito yung sinabi ko kanina, na pag nasa first energy level, isa lang yung orbital, S lang. But we have to label that as 1S. Kasi to distinguish, kailangan may distinction sila. Kaya sila 1S, 2S, 3S, 4S to indicate their position in the atom according to energy level. So 4S, ibig sabihin, nasa fourth energy level. Pag nasa second energy level ka, dalawa yung orbitals. Nabanggit ko na, S at saka P. Pag nasa third, tatlo, S, P, and D. Pag nasa 4, S, P, D, and F. Pag nasa 5, S, P, D, and F lang din. Kasi from 4 to 7, taga-4 lang, S, P, D, F. Okay? Ang S orbital, dahil isa lang yung ikot niya, according to Pauli exclusion, every orbital can hold only 2 electrons. Kung meron lang tayong isang S orbital, ang maximum electron na kaya niyang i-hold ay 2 lang. Ito yung clockwise, counterclockwise, kaya 2 lang. No more than 2 electrons can occupy an orbital. 2 lang. It can have less, pwedeng isa lang yung laman ng orbital, pero hindi siya pwedeng maging 3 or more. 2 lang ang maximum according to Pauli exclusion principle. So pag nasa first energy level, 2 lang yung electrons na meron. Pag nasa second energy level ka, dahil 2 yung orbitals, mas marami yung electrons, 8. Bakit 8? Ang S ay 2 lang ang kayang i-hold. Ang P, dahil 3 yung possible orientations niya sa space na nabanggit ko kanina, ito siya. Bawat isa according to exclusion, Pauli exclusion, 2 ang pwedeng ma-hold. So, dahil meron tayong 3 p orbitals, ang maximum na pwedeng i-hold ng p orbitals ay 6. Kaya in the second energy level, you have a total of 8 electrons. Pag nasa third ka, meron kang addition of d orbitals at meron tayong 5 d orbitals. So, kung ang d orbitals natin ay 2 bawat isa, we have a total of 10. So in the third energy level, we have a total of 18 electrons, 2 from S, 6 from P, and 10 from D. Pag nasa fourth, as you go higher energy level, tumataas yung number of electrons due to addition of orbitals, due to increase in the number of orbitals. Ano ba yung electron configuration? We've been mentioning about electron configuration. Will you read? Yes, Miss Fiona?
The distribution or arrangement of electrons is different orbitals within their respective sublevel.
Okay, na-mention ko na ang configuration ay distribution of electrons. So we now know how to determine the number of electrons to distribute. The question is, how are these electrons distributed in the different orbitals? And that is about electron configuration, the distribution of electrons in the different orbitals in the different energy levels. Ang distribution po is guided by the following rules. So meron tayong Pauli exclusion, principle of Bow principle, and Hans rule. So ang distribution natin ay hindi basta-basta. Pero we can be guided by the mnemonics. So this is how, this is what we see in the distribution. 1s2, 2s2, 2p6. Bakit 2? Bakit 6? Bakit 10? Bakit? Nasabi ko na kanina, ang s orbital ay isa lang ang ikot sa space. So we only have a maximum of 2 electrons. Kaya lahat ng S dito, be it in the first energy level, second, or seventh energy level, 2 lang ang kanyang electrons. Ang P, lahat naman sila ay 6 kasi ang maximum ay 6 for P. Ang D, 10, ang Fi, 14. Pero ang order ng pag-fill up ay according kay of-bow principle naman. Mabilis ma-fill up ang S. Kaya mapapansin niyo sa bandang gitna, mauuna yung 4S bago yung 3D. Bago yung 4P, nauna muna yung 4P, nauna muna yung 5S. Kasi may energy requirement ito. Pag nag-fill up ng orbitals, may energy requirement and they are increasing from S. S requires lowest energy, F requires the highest amount of energy. May energy requirement sila. Kay Hans rule naman, yung pag-distribute sa different orbitals. Hindi siya tatlo yung p orbitals, dalawa, dalawa, dalawa. Hindi ganon. Ang pagdidistribute ay isa, 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 lahat clockwise, isa, isa, isa ulit, counterclockwise. I'll have this discussed further next week kasi wala na tayong time. Pero just in passing, para malaman yung number of electrons, look at the periodic table. Lithium is 3 atomic number. So that gives us the number of electrons, 3 to distribute. So paano nyo i-distribute yung 3 electrons? Follow the mnemonics. Kasi this is according to the guidelines na. Yung tatlong guidelines of Pauli exclusion, Hans rule, at saka Pauli exclusion, Hans rule, and of-bow principle. Naka-base na doon yung order na ito. Susundan na lang natin. Susundan na lang. 1s2, hindi pwede maging 1s3. Ang maximum kasi ng S ay 2 lang. Pero pwede siya maging 1s1. Hydrogen 1s1. So kung ilan yung kailangan mong i-distribute, move on ka lang ng move on dito. Continue, continue, continue distribution hanggang sa ma-reach mo yung required number of electrons to distribute. So ang lithium po aabot hanggang 2s. Hindi kailangan ma-maximize ang 2 sa 2s kasi 1 na lang yung, na-distribute mo na yung dalawa sa 1s eh. Kailangan mo na lang ng isa, so 2s, 1 na lang. Nitrogen is 7. Distribute 7. Mag-start ka dito, sundan ulit ito. Mauuna yung 1s2, followed by 2s2. 4 ka na yun doon. 3 na lang yung kailangan. Ang P can hold maximum of 6, pero hindi mo kailangan i-maximize yung P. 3 na lang, so P3 na lang. So that goes for the rest. So ang neon, mako-complete mo yung 2p6 kasi you need to distribute 10 from the atomic number. So how do you count the number of electrons? Yung mga parang exponent nila. 2 plus 2 plus 6 is 10. Yung malaking number, sabi nga dito ay energy level, P is the orbital, and 6 is the distributed electrons in the orbitals. Okay? Yung orbital diagram naman makes use of boxes. Yung mga blocks na to, bawat isang block represents an orbital. So kung meron kang p orbitals, ang boxes mo dapat 3. Kasi we have 3 types of p orbitals. Pag d ito, dapat 5. Pag f, dapat 7. Yung mga arrows naman, arrows are electrons, representations of electrons. Arrow up meaning clockwise. The electron is spinning clockwise, downward, counterclockwise. Notice that in each box, there are 2 arrows lang. Kasi sabi ko nga, according kay Pauli exclusion, only 2 electrons can occupy an orbital. And these 2, according to Schrodinger, sa quantum numbers niya, are spinning clockwise and counterclockwise. So that's how you assign the arrows as representation of the 2 electrons spinning clockwise and counterclockwise in that particular orbital. Okay? So, these are examples. Ito mga kompleto. 1s2, ayan, pag umabot yung distribution mo hanggang 3d10, ang complete orbital diagram niya ay ganito. Ito po sa D. Tingnan natin sa D. Pag umabot sa D yung ano ba sa silver, aabot siya sa D. Kasi ang daming electrons, 47. Ito po yung 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, at ito yung 3d10. So ito yung complete distribution of electrons in the orbitals. This is the complete orbital diagram pag ang distribution mo ay umabot ng 3d10.